Hi everyone, welcome to MyMax Academy. In this video, we'll continue with the chapter relations and functions, which is the first chapter from your 12th standard CBSE mathematics. We'll continue with example 10 in page number 9 in your textbook. So example 10 is what is given. So given is f is a function from n to n, set of all natural numbers to set of all natural numbers, and it is given by f of 1 is equal to f of 2 is equal to 1, which means f of 1, image of 1 is also 1, 1 is an image of 1, 1 is also image of 2, f of 1 equal to f of 2 equal to 1, and f of x is equal to x minus 1 for x is greater than 2. Whenever x is greater than 2, then it is f of x is x minus 1. If x is equal to 1, x is coming from n, so it starts from 1, 2, 3 like that. So if it is greater than 2, this function, if it is equal to 2, if it is less than or equal to 2, which means if x is 1 or 2, then if x is 1, then f of x is 1. If x is 2, then f of 2 is also 1. When x is 3, then f of x will become 3 minus 1. That will be 2. So that's how the function is defined. I will draw the arrow diagram and then I'll explain you. So what we have to prove? To prove is, we have to prove that it is on to but not 1 to 1. First is we should prove f is, we'll say not 1 to 1. We have to prove f is not 1 to 1. And second, what we have to prove is f is on to. F is an on to function. Right? Now again, let's draw the arrow diagram. Let's represent the function using arrow diagram. So this is n and this is n. Natural numbers, so we have 1, 2, 3, 4, 5, 6, like that will go. Here also 1, 2, 3, 4, 5, 6, dot, dot, dot. Now 1 goes to where? When x is 1, what is f of 1? F of 1 is 1. So this is this one, and this one goes to this one is this one. So this f1 goes to 1. F of 2, if I put 2, so 2 I cannot put in this function because only when x is greater than 2 I can use this function. But x is equal to 2. When x is equal to 2, I have to go here. When x is 2, what is f of x? That is also 1. So 2 also goes to 1. 2 also goes to 1. And 3 goes to now x 3. 3 means x is greater than 3. So then 3 means x is 3. When x is 3, then this condition is satisfied. X is greater than 2. 3 is greater than 2. X is 3. So I have to use this function. Now what is f of 3? My f of 3 will become 3 minus 1, which is 2. So my 3 will go to 2. What is my f of 4? Is 4 minus 1. I cannot use this function when x is equal to 1 or x is equal to 2. I cannot use this function because this function f of x equal to x minus 1 can be used only when x is greater than 2. Only when x is greater than 2. So for 4 I can use this function because x is greater than 2. 4 is x. So 4 is greater than 2. So f of x is x minus 1, which means 4 minus 1, which is 3. So 4 goes to 3. Then 5 goes to 4. 6 goes to 5. So that's how similarly other everything goes. 7 goes to 6, 8 goes to 7, so on and so forth. Now we need to show that this function is not 1 to 1. Solution. See, this function is not 1 to 1 because if you draw the arrow diagram, you clearly see that both 1 as well as 2, both of them go to the same image. Two different elements. 1 and 2 are two different elements. They are going to the same number here. So it is many to one function. It's not a 1 to 1 function because two elements have the same image. When two different elements have same image, then it is not 1 to 1. Two different images should have different images. Two different elements in this set, which is domain, should have two different images in the set codomain. So therefore it is not 1 to 1. So we'll go by the definition of f of function to be 1 to 1. So which means we will say 1 equal to 1. This 1 is same as 1. This will look like, what is this? 1 equal to 1 is so obvious. Yes, 1 equal to 1 is so obvious, but still we'll write. But this 1 can be written as f of 1 because 1 can be written as f of 1. Even this 1 can be written as f of 2. 1 can be written as f of 1. 1 can also be called as f of 2. But so which means f of 1 equal to f of 2. But does it mean that 1 equal to 2? No, 1 is not equal to 2. So which means what we have got? We have got f of x1 equal to f of x2, and we got that implies x1 is not equal to x2. When the images are same but the numbers are different means two different numbers are having the same image. Therefore, it is not 1 to 1. So we got the condition. So f of x1 equal to f of x2. Here x1 is 1, x2 is 2. So f of x1 is equal to f of x2, but 1 is not equal to 2. Therefore, f is not 1 to 1. Because two different elements which are 1 and 2, two different elements, they have the same image 1. F of 1 is also 1, f of 2 is also 1. So two different images have same, two different elements have same image. F is not 1 to 1 because the image is same but the elements are not same. So two different elements have same image. Therefore, f is not 1 to 1. Now we have to show that f is onto. We have to show that f is onto. To show f is onto, we must show that every element here should have a element here such that f of this element is equal to this. So every element here should be image of some element. We have to prove that. If I take any number here, I should be able to find an x here such that f of x, that x should be mapped to this y. Any y that I find here, I should be able to find an x such that f of x should be mapped to y, which means f of x equal to y. That is the definition of onto. Every element here should have a x here such that f of x is y. Even if one element fails, then it is not onto. So here they are saying it is show that it is onto. So it is onto. We have to prove that it is onto. Now for that, what do we do is we'll take one element y belonging to n. We'll always take some element y from this set, which is the codomain. Codomain. We have taken the element from a codomain, and we should be able to find an element in domain. Such that f of that element in domain should be equal to the y which is in codomain. Now we took an element y belongs to n codomain. From the codomain we have taken one element. Now that element can be of two types. That is, suppose if case 1, if this y is equal to 1, suppose any element that I took from here, suppose that element is 1, what happens? If that element is 1, then 1 definitely has an x here. 1 is an image of 1, 1 is also image of 2, it can have many images. This can be image of many numbers, but at least I should be able to find one x such that this is the image of that x. So when y equal to 1, case 1 is y equal to 1. If y is equal to 1, then there exists x equal to what? X is equal to 1. There exists x is equal to 1. We are able to find one. This one. See, this one y equal to 1 is this one. For this one, I am able to find an x in this set. That is also 1 because 1 is mapped to this. You can also say 2. We can also say y equal to 1. For the same one, I can find an x equal to 2 also I can say. So because f of 2 is 1. Either I can take x as 1 or x as 2 because both of them are going to this. Any one will be okay because we need at least one x, but here we have two x's, 1 and 2. For the same y, we have two x's. We can have many x's, but at least we should find one x. Then only it will be onto. So if y is 1, then there exists x is equal to 1 such that what is f of 1? F of x is 1. F of x is 1 means f of 1 is 1. Right? So when y equal to 1, then there exists x is equal to x is also 1. That says that f of 1 is 1. And f of 1 is 1 is given in the question. Now if y is not equal to 1, case 2, if y is not equal to 1, then what will be our x? When y is not equal to 1. Case 2 is y is not equal to 1 because we need to check for all the elements in n. If the element that I am taking from n, which is y, which I am calling that as y, any element, I am taking one number. If that number is 1, which is this element. Suppose had I taken this element, then it has 1. The corresponding x is 1, such that f of x is 1. Right? For this one, I am able to say that this is the image of this. I am able to find an x here. Suppose if y is not equal to 1, suppose the element that I randomly took from here, any element that is not 1. So suppose if I have taken 3 or 4 or anything other than 1, any number starting from 2 to the rest, then what should be my x? For 1 it is very clear. We can't say if 2 then it is 3. I am randomly taking number y. Y is not equal to y means y can be anything now. Y can be 2, 3, 4, 5, any number. So generally we have to prove. So if y is not equal to 1, then what will be our x? Then there exists, we should still say there exists x is equal to, now you should find the value of x. To find the value of x, you have to write, you have to use this function and put this value in the rough work. Put this as f of x is equal to y. Put here f of x is equal to y. Put it like this. And what is f of x? F of x is x minus 1. So you write x minus 1 equal to y. From this find x. X is what? Y plus 1. The 1 goes this side. Minus 1 goes this side. So then you write that. Because when y is not equal to 1, whenever your y is not equal to 1, right? Then these are coming from where? These mapping we got 2, 3, 4, 5. These mapping we got from this function. These mappings we got from 2. 3 goes to 2, we are saying how? Because of this. 4 goes to 3, how? Because of this. And these are what function? This function. So we have to go back to this function and put that equal to y, x minus 1 equal to y, and then find x. So this is the same procedure that we will do for every problem. Wherever you need to prove that it is onto, you should write x in, you have to put f of x is equal to y in the rough work. Don't show it as the main work. In the rough work and try to find x is equal to y plus 1, and we have to make sure that y plus 1 is also a natural number. It should be present here. I can always write any function in terms of x in terms of y. So x is equal to what? Y plus 1. Now the question is this y plus 1, does it belong to this set? Y is here. Y plus 1 is here. But what is y? Y is not equal to 1. And y is coming from where? N. Y is a natural number and y is not equal to 1 means y will be 2, 3, 4, 5, whatever. The minimum value is 2. If y is 2, x will be 3. So which is a natural number. If y is 2, y is a natural number means y plus is also a natural number, right? If y is a natural number, if y is a natural number, y plus 1 is also a natural number. Y is a natural number means if you add 1 to any natural number, you will still get the natural number, right? So x is equal to y plus 1 is also a natural number, belongs to n, is also a natural number. And this n is what? This n is domain. Domain such that now we should find what is f of x. F of x is what? We have to show that f of x is equal to y. F of x is equal to f of what is x? X is y plus 1 equal to. Now we need to go and use this function because x is greater than 2. What is x? X is y plus 1. X is y plus 1 and y is not equal to 1. When y is not equal to 1 means what? Y should be at least 2. Y is a natural number and y is not equal to 1 means y should be at least 2. Minimum it should be 2. If y is minimum 2, then x will become what? 2 plus 1 is 3. Your x becomes 3. When your x is greater than 2, your x is what here? 3 now. Minimum it will be 3. It cannot go lower than 3. So all this number y plus 1, the minimum value will be 3. Because the minimum value for y is 2. Because it cannot be equal to 1. If y cannot be equal to 1 means y has to be 2. Because y is a natural number. So y should be minimum 2. If y is 2, x should be minimum 3. Which means x is greater than 2. Because x is 3 minimum. So if it is greater than 2 means we have to use this function. So what is f of y plus 1? F of y plus 1 will be, take this function. F of x means x minus 1. In the place of x, you have to put y plus 1 because our x is y plus 1. So here x minus 1 means x minus 1. So this is your x. So f of x is x minus 1. F of x is, so wherever in the place of x, I have to put y plus 1. Well, I have to find f of y plus 1. Which means in the place of x, I should put y plus 1. Then this will become y plus 1 minus 1. Now this minus 1 plus 1 get cancelled. we'll get y. So we got f of x is equal to y. Therefore, f is on 2. Which means for every y, whether it is equal to 1 or not equal to 1, there are only two cases. Because if y is equal to 1, then we cannot use this function. Because if y is equal to 1, then y plus 1 will become 2, but x will be equal to 2. But only when x is greater than 2, I can use this function. When x is equal to 2, I can't use this function. So that is why we are treating this y separately. Y equal to 1. If I take the element, if that element happens to be 1, then immediately I know I am able to find an x here. Or you can even say f of 2 is 1. I can even say x is equal to 2, such that f of 2 equal to 1 also I can put, or f of 1 also equal to 1 I can put. So which means if for this element I am able to find an x. But for rest of the elements, correspondingly for every element I am able to find this, yes. The other part we have proved. For these elements, 2, 3, 4, 5, 6, 7, the rest of the elements, this is the proof that we are able to find an x in the domain such that f of x is equal to y. Therefore, f is on 2. Fine. All of you pause the video, take the notes. I'll go to the next problem. Example 11. It's an easy one. Example 11. So, example 11 is what is given. So, given is, in example 11, given is show that the function f from R to R. F is a function from R to R. So, here I am not putting stylish R. You can understand that it is not a relation because we have come out of the relation section. We are into function. So, this R represents real numbers. Right? So, I can put probably dark line or whatever. Or the stylish R I should put. Set of all real numbers defined by f of x is equal to x square. Right? And what we should prove? We should show that is neither 1 to 1 nor on 2. Which means we should prove that f is not 1 to 1 and f is not on 2. Neither 1 to 1 nor on 2 means f is not 1 to 1, f is not on 2. We have to show that. Fine. So, how do we prove this? That f is not 1 to 1, f is not on 2. See how this one, if you want to look at this function, how it is. Right? So, if you try to draw the arrow diagram for this. This is R, this is also R. It will have all the numbers 1, 2, 3, minus 1, 0, 1, 1.2, root 2, 3, all 1 by 2, everything. 1, 2, 3, minus 1, 0, 1.2, 2.4, root 2, root 3, pi, 3, 1 by 2, all the real numbers, dot, 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 dot. All the real numbers, collection of all the numbers. Now, how it is? F of x is x square, which means 1 will go to 1 square. 1 square is 1. 1 will go to 1. 2 means if I put 2 square, it will go to 4. 4 is suppose here. It will go to 4. 3 will go to 9. Minus 1 will go to 1. 0 will go to 0. 1.2 will go to 1.414. 1.44. Because 1.2 square is 1.44. Root 2 will go to 2. Because square of that. Root 2 the whole square. So root 2 will go, 3 will go to 9. This 3 I have already listed. I will not. So 1 by 2 will go to 1 by 4. Because 1 by 2 square is 1 by 4. 1 by 2 will go to 1 by 4. Right? So if I take minus 3 will also go to 9. If I take minus 2 will also go to 4. So 2 also goes to 4, minus 2 also goes to 4. Right? So clearly from the arrow diagram you can see that it's not 1 to 1 because 1 also goes to 1, minus 1 also goes to 1. So it's many to 1 function. It's not 1 to 1 function. Right? So that we can immediately prove. We can say f of 1 is also 1. F of minus 1 is what? F of 1 is 1 square which is 1. F of minus 1 is what? That is minus 1 the whole square which is also 1. So f of 1 is equal to f of minus 1. Both are 1. F of 1 and f of minus 1 both are giving you 1. But 1 is not equal to minus 1. But they are different. Therefore, it is not 1 to 1 because two different elements, they have the same image which is 1. The two distinct elements are going to the same image. 1 also goes to 1, minus 1 also goes to 1. So, two different numbers going to single number. There is many to 1 function. Many are going to the same. So, therefore, it is not 1 to 1. Therefore, f is not 1 to 1. F is not 1 to 1. F is not 1 to 1, right? Now we have to show F is not onto. To show F is not onto, we should be able to find at least one element here which is not image of any of the elements here. For at least if I can find one element such that there is no element here such that it goes to that. So suppose if we take -1, which element will go to -1 here? So whatever value I put for x square will be always positive. So all these numbers that I have mapped, all are going to the positive numbers, right? So -1 also goes to 1, -1 doesn't go to -1, -1 also goes to 1. So which means all these negative numbers, -2, -3, -4, none of them will have any x here. Because no number will be mapped to -1. No number here will be mapped to -2. No number will be, because this is x square. This is x. This is your f of x. This is your y, which is equal to x square. This is your x. So whatever x, it goes to y, x is equal to y equal to x square. So which means if I take an element here that is negative, no number will be mapped to a negative number. Because all these numbers will go only to the positive numbers here. Because y equal to x square is always positive. Right? So which means if I take any negative number from here, you cannot find any number in this such that f of x is negative. You cannot find f of x equal to a negative number because f of x is x square and x square cannot be negative. It can be either 0 or positive because x is the real number. So that's why we show that it is not onto. We'll take one element. We'll say, we can even say -1 belongs to. -1 belongs to, or we can take any negative number. We'll take -2. Okay, -2 belongs to R, and this R is what? This R is our codomain. Codomain, which is this R. Codomain. -2 belongs to our codomain, but there does not exist any x. There does not exist any. There does not exist. Write it here. Any x belonging to the another R, which is this R, which is domain, such that f of x is equal to -2. F of x is equal to f of x is equal to y. Y is -2. For this this y is -2. You cannot find any x. That does not exist any x in R. You cannot find any x such that will go to -2. Whatever, if you put -2 goes to 4. 2 also goes to 4, -2 also goes to 4. If you take √2 goes to 2. -√2, that will also go to 2. -√2 also will go to -√2, the whole square is what? +2. So none of them will go to -2. Which means there are all the negative numbers, they don't have any number in x in this set domain such that f of this number is equal to -2 or the negative, any negative number. So none of the negative numbers can be image of any of the numbers here. Therefore it is not onto. So therefore f is not onto. It's not onto means onto function. Fine. So f is not onto. F is not an onto function. So here we have proved that f is not an one-to-one function. F is also not an onto function. And so all of you can pause the video, take the notes. I'll go to the next example, which is example 12. Important. Example 12 is example 12. Fine. Which says, so what is given is f is a function from n to n, set of all natural numbers to set of all natural numbers, n to n, and it is defined as, f of x is defined as x plus 1 if x is odd. If x is an odd number, we have to use this function, and it becomes x minus 1 if x is an even number. X is an even number. And what we have to prove that? We have to show that it is both one-to-one and onto. What do we have to prove? We have to prove this. We have to prove f is one-to-one, and also we should prove f is onto. To prove that f is one-to-one and f is onto. It's an important problem. Now, how do we show that f is one-to-one? How do we show that f is onto? Now how this one looks like, I will try to draw this diagram. It's not required to draw for every problem, or even you need not draw it, but I am drawing it because I want you guys to understand how the function definition is, so that will help you to understand the problem. Once you understand the problem, you need not draw this error diagram and show how it works in the exam, or even any test you need not show that. But if you are not comfortable, you can always draw that in a rough area, and then you can, for your understanding, to see how it looks, whether it is already becoming one-to-one or on-to or not one-to-one and all that. So I will draw this arrow diagram. Now this is one set n to n, set of all natural numbers to set of all natural numbers. The function is going f is a function. Now how it is so again it will have 1 2 3 4 5 6 and all dot 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 1 2 3 4 5 6 dot dot dot. Many numbers are there. Now 1, if I take 1, now 1 is one odd number. When x is odd, I have to use this function. I take x is equal to 1 first. So these are x, these are f of x, which is y. If x is 1, I put x is equal to 1 is what? Odd. So if I take x1, don't put it in this one, because there are two definitions for f of x. Depending on the value of x, we have to choose which definition we have to use to find the corresponding value for x, so or the image of that. So 1 is odd, so I have to put here. So 1 plus 1, 2. So 1 will go to 2. Now second 2 is what? Even. Even means I should put here 2 minus 1 is 1. So 2 will go to 1. Then 3 is odd number. Odd number means x is odd means x plus 1. So 3 plus 1. So 3 will go to 4. 3 will go to 4. 4 will go to 3. Because 4 is even. Even means f of x is f of 4 means 4 minus 1. If I want to find f of 4 means 4 minus 1, because 4 is even. Even means this function. So 4 minus 1, which makes it 3. So 4 is mapped to 3. Right? 4 is mapped to 3. So this 4 is mapped to 3. So similarly 5 will go to 6, 6 will go to 5. So that is how this mapping is. We have to show that it is 1-to-1 and onto. We have to show that it is 1-to-1 and onto. So it looks like, looking at the arrow diagram, looks like it's 1-to-1 and onto. But we need to prove that. We need to prove that. So we will have different cases to prove that. Right? So now to prove that it is 1-to-1, we have to prove that f is 1-to-1. So to prove f is 1-to-1, what is it? We have to take two elements x1 and x2 from the domain such that their images are same, such that f of x1 equal to f of x2, and then we should prove x1 equal to x2. So we'll say let x1 comma x2 belongs to n, and this n is what? Domain. Such that f of x1 equal to f of x2. F of x1 equal to f of x2. Now we should show that x1 equal to x2. And show that x1 equal to x2. Now for that, now what is f of x1? Now what is f of x? F of x has two values depending on the value of x is odd or x is even. Now here it is x1. We have taken two numbers x1 and x2. Right? And we want to find f of x1 first. And then we have to find f of x2. First we will try to find what is f of x1. But x1 is, f of x1 depends on what is x1. If x1 is odd, we can use this function. If x1 is even, we will use this function. But we don't know what x1 is, odd or even. We don't know. We don't know whether x2 is odd or even. If we know x2 is odd, we'll use this function. F of x is x plus 1. If we know that x2 is even, we'll use f of x is x minus 1. But we don't know what is x1 and x2, whether they are even or odd. If we don't know what they are, then we need to have cases. We have taken two elements. Now we should have cases. So case 1 is, if both are even, let's assume both are even. Case 1 is both x1 and x2 are even. Both are even, what happens? And then we should have another case where both are odd. Third case is one is even, one is odd. Anything can be even, anything is odd, then what happens? So that will cover all the possible combination. When you have two numbers, either both are even or both are odd, or one is even, the other one is odd. So first case is when both are even. When both are even, now we know both are even. And our f of x1 equal to f of x2 from here. Now what is f of x1? We know x1 is what? Even. When x1 is even, I have to use this function. I know x1 is even because we have taken the case where both are even. So x1 is even. x1 is even means my f of x1 will become x1 minus 1. If f of x is x minus 1, f of x1 will be x1 minus 1 equal to f of x2 we have to find. x2 is also even. So x2 is even. Therefore, my f of x2 will be x minus 1 means x2 minus 1. Are you guys clear? Fine. So now this minus 1 will get cancelled both the sides. So your x1 equal to x2. What we got? x1 equal to x2. So we started with f of x1 equal to f of x2 and we got x1 equal to x2. So this shows that f is 1 to 1 when both are even. So for case 1, therefore f is 1 to 1. F is 1 to 1, not totally we can say this f is 1 to 1 for all x1 and x2. It is 1 to 1 when x1 and x2 both are even. Which means for case 1 it is 1 to 1. Now, case 2 also we should prove it is 1 to 1. Case 3 also we should prove it is 1 to 1. And we have only 3 cases. Once all the cases it comes 1 to 1, then we can say therefore f is 1 to 1 for all the x1, x2 from the domain. So that makes f as 1 to 1 for the entire domain. Now case 2. Case 2 is both x1 and x2 are odd numbers. Then what happens? Both x1 and x2 are odd natural numbers. Then when both are odd, then what happens? Again f of x1 equal to f of x2. This is true. This is how we started this. Then we are having different cases. So f of x1 equal to f of x2 and x1 and x2 both are odd. So f of x1 is what? X is odd. X is odd means my f of x1 will become x1 plus 1 equal to my f of x2. x2 is also odd. When x2 is odd, I have to use this function. So f of x is x plus 1 means f of x2 will be x2 plus 1. x2 plus 1. Now again this plus 1 will go. Or you can take this plus 1 goes this side, it becomes minus 1. So plus 1 minus 1 becomes 0. So you get x1 equal to x2. Therefore in this case also f is 1 to 1. Case 2 also f becomes 1 to 1. So which means when x1 and x2 both are even also f is 1 to 1. When both are odd also f is 1 to 1. Now we should take the case where case 3 where one is odd and other one is even. You can take anything as odd. So we'll say x1 is odd and x2 is even. In this case, we need not have the fourth case saying x1 is even and x2 is odd, because one of them should be even, one of them is odd. Right? So both the cases are covered here. x1 is odd and x2 is even, or this is also same as x2 is even, x1 is odd. Both are covered here. So there are only 3 cases net to net. Both are even, both are odd, or one is odd, the other one is even. So you can take one of them as odd. You can take x1 as odd or x2 as odd. If you take x2 as odd, you have to put x1 as even. Now and f of x1 equal to f of x2. Now what is our f of x1? x1 is what? Odd. x1 is odd means odd. I should use this function. So this will become x1 plus 1 equal to f of x2 is even, which means x2 is even. So f of x2 is 1. f of x2 will become x2 minus 1. So x2 minus 1. Because it is x2 is even. Even means I have to use this function. So for x1 we use this function, for x2 we use this function, because x1 is odd, so we use this function. x2 is even, so we use this function. So now don't cancel plus 1 and minus 1. So they are on the opposite side. So take both of them to one side. So I will bring this x2 to x1 to this side and this minus 1 to this side. Then we'll get what? We'll get 1 plus 1 equal to x2 minus x1. This minus 1 comes here, it will become plus 1. x1 goes there, it will become minus x1. So we get x2 minus x1 as 2. 1 plus 1 is 2. But there is a problem here. What is the problem? x1 is an odd number, x2 is an even number. How can a difference between an even number minus odd number cannot be an even number? Difference between an even number and an odd number will be always an odd number. Difference between even number and an odd number will be always an odd number, but here we are getting as an even number, which means this case is not possible. Which means when x is odd and x2 is even, then their images cannot be same. Their images cannot be same. So therefore this is an invalid case. So we will say x2 minus x1 equal to 2 is not possible. The above is not possible. Above is not possible. Above case is not possible. The above the above case is not possible, because we need not worry about this case at all. But this is not possible, because if I take x as x1 as odd and x2 as even, I am getting x2 minus x1 as 2. How can this be? How can the difference between odd number and even number be 2? Which means this cannot be true at all. Images can never be equal. When x is odd and x1 is odd and x2 is even, then images have to be different. Because x1 and x2 are obviously different, and the images have to be different. Images are same means then you are getting x2 minus x1 as 2, which is not possible. Therefore, this above case itself is invalid. Above case is not possible. So we need not, we can ignore this. If it is not possible means we can ignore this case and we can conclude f is 1 to 1 from these two cases. Therefore, we can say therefore f is 1 to 1. This f is 1 to 1 is not for this case, for the overall. Case 1 also 1 to 1, case 2 is 1 to 1, case 3 is not possible. So ignore this. This is 1 to 1, this is 1 to 1, it is shortly 1 to 1. Therefore, f is 1 to 1 function. So what we have proved here? We have proved f is 1 to 1. Now we have to prove f is onto. We have to prove the f is onto. Now for that onto case, again for onto. So this is the proof for onto. Onto again, what we'll say? We'll say let we take one element y from this set, and we should show that there is an element here whose image is y. That element is getting mapped to y. Any element that I take here, I should be able to find another element in domain such that f of that element should be equal to this element, the element that I took from the codomain. So we'll say let y belongs to this one, n. Let y belongs to n. Then we should be able to find an x in this set. So I am taking a y from this set. Y is coming from here. If there is a y here, I should be able to find some x here such that f of x should be equal to y. F of x should be equal to y. And that should be true for any y that I take, I should be able to find an x. Which means for every y there is an x. We will prove that for every y there is an x. So every y there is an x means f becomes onto function. F becomes an onto function. So we will say let y belongs to n. Now the moment y belongs to n, now again I told you in the rough diagram we'll put in the rough work we'll put f of x is equal to y, and then we'll write x in terms of y and all that to prove onto. Now when y is equal to n, again here the value of your y, this is your y, your f of x is this is your y. Your y is x plus 1 or your y is x minus 1. Your f of x is called as y. Again your y is, the y value depends on x is odd or even. So again here we should talk about two cases, because here again your y is coming into two possibilities. Your f of x can be any one of these two. So which means again we should have two cases to treat y as, if I take any element here, if I take any element y from this set, then we should have two cases saying if y is even, then we should be able to find some element. If y is odd also, we should be able to find some element. So when we take any random element, we have to have two cases. Suppose if y is even, also we should show it is onto. If y is odd also, odd number also, we should show it is onto. Once you show for both the cases it is onto, here we need not worry about three cases because it is only one element. There are only two cases possible, either y is odd or y is even. So whenever you see a function is differing based on x is odd or x is even, this will get into these cases like this. If your f of x is not a straight one single function like f of x is equal to 2x or f of x is equal to x square, then you need not worry about the case. But when your f of x is depending on the value of x, whether it odd or even or greater than 0 or less than 0, some condition, if your function value depends on some condition of x, then we will get into cases, right, depending on how f of x is behaving. Here f of x is behaving based on even or odd, so we should take even, odd, even, both are even, both are odd, one is even, one is odd. Whenever you take two elements, here only one element, so we have odd or even, so we should have two cases. So let y is equal to, y belongs to n, right? Case 1 is y is odd. If y is an odd number, suppose if y is an odd number, then for every odd number, are we able to find that element here such that f of that element should be equal to that odd number y? So odd number y. Now y is odd. Y is odd. Now again, when y is odd, right? Y is odd. Y belongs to n, and this n is codomain. See, for 1 to 1, we will always start. We'll take the elements from the domain, and we'll take 2 elements from the domain. For on to, we'll take only 1 element, that is from codomain. For all the problems, this is the rule that we will follow. This is the rule we must follow. So y is odd. Now if y is odd, now we should be able to find the x. We should be able to find the x such that f of x is equal to y. Now y is odd. Now when y is odd, we have to see whether y is in this form or in this form. Because we have to put in the rough work. We have to put f of x is equal to y. Now for f of x, what I will put? Whether I will put x plus 1 or x minus 1 here. That we don't know. But now here we know, in this case we know because y is odd. If y is odd means which will be odd here. So if y is odd, what should be x? If x is even, then y will become odd. So suppose if x is even. X is even means x minus 1 is what? Odd. Because x is even means x minus 1 will be odd, and x minus 1 is y, and y is odd. So which means y is odd means what? Your x should be even. Your x should be even. So which means your x is even means what? Your x is even means you should choose this function for this. So we should put f of x as x minus 1 equal to y. Fine. Because y is odd, y will become odd in these two. Which is odd? This is odd or this is odd? How do you find that? That is based on x. X is even. X is even means what? X minus 1 is odd. Here x is odd. X is odd means x plus 1 is even. So this is even, this is odd. When I say y is odd, y cannot be this because here it is even. So y has to be this. So y should be equal to, so x minus 1 should be equal to y. So I should put f of x as x minus 1. From this we have to find what is the value of x. X will become y plus 1. Then we should say y is odd. Case 1 is y is odd. Then case 1 is y is odd. If y is odd, then for y belonging to n, which is codomain, I'm writing this statement again, codomain. For y belonging to n, codomain, there exists x is equal to y plus 1 such that my f of x is equal to f of y plus 1, that is equal to f of y plus 1, that is equal to, but y is what? Y is odd. Because we are dealing with the odd case. Y is odd means y plus 1 is what? Even. And but y plus 1 is what? X. So x is even. X is even means I have to use this function. So I will put x minus 1. My f of x is what? X. I have to use this function, not this function. So x minus 1. So which means x is y plus 1. This is your x. F of y plus 1 means this is x. So x minus 1. X minus 1. X is my y plus 1. So that will become plus 1 minus 1 will go, I'll get y. So I have put f of x is equal to y. So therefore we can say, I'll erase this. I'll put the line here. Therefore f is onto. F is onto for what? F is onto for the case 1. Now we have to show that f is onto for the case 2 where y is even. So case 2 is y is even. Y is an even number. Now if y is an even number, then which is an even? This is even or this is even? We know this is even because x is odd. If x is odd means x plus 1 will become even. And these are our y's. So definitely our y should be equal to x plus 1. Y should be equal to x plus 1. So we have to do it in our rough work. We should write like this. So f of x is equal to y, which means y is even. Even means my x is odd. I should use this function. Here is what y will become even. So x plus 1 equal to y. My x will become y minus 1. This plus 1 will goes this here. This side it will become plus 1 goes to the right side. It becomes minus 1. So y is even means what happens? Again we should say for y belonging to n codomain. Y belonging to n codomain. there exist x equal to, what is our x? X should be equal to y minus 1. So in this case, your x is equal to y plus 1. X is equal to y plus 1. In this case, your x is y minus 1, such that f of x is equal to f of y minus 1. And what is f of y minus 1? Y is even. If y is even, y minus 1 is odd. From the even number, if you subtract 1, it will become an odd number, which is our x. X is an odd number. If x is odd, which function we will use? This function. So x plus 1. So f of x is x plus 1. So f of x is x plus 1. Here, f of y minus 1 will be x. X is y minus 1 plus 1. That is called as f of x is x plus 1. F of x is x plus 1. In the place of x, I have y minus 1. So in the place of x here, I have to put y minus 1. Now that will become y. Because plus 1 minus 1 will get cancelled. I will get f of x is equal to y. Therefore, f is onto. So for the case 1 also we got f as onto. And for case 2 also we have got f as onto. Right? Therefore, f is onto for all y belonging to n, which is codomain. N is that codomain. Therefore, f is onto for all y in n. Right? Or we can just say f is onto, doesn't matter. You need not even write this, that's okay. We can say f is onto because both the cases, case 1 also it is onto, case 2 is also it is onto. So therefore we can say finally therefore f is onto. Therefore again we can say f is onto. So we have proved f is 1 to 1 and also we have proved f is onto. So we have proved both. Fine. So all of you pause the video, take the notes, and you can watch my next video for the continuation of this. Thank you for watching. See you all in the next video. Thank you.